Greetings, the Astro 30 here yet again working on this amplifier project. Today we're going to look at a headphone adapter circuit so it can connect directly to the power amplifiers. It's basically a voltage divider, and we're looking on Rod Elliott's Elliott Sound Products website because he has a circuit for one. Very handy. Only thing is there's no PCB for this version which we're looking at, which is version 1. There's 2. However, there is now. So looking at the circuit here, it consists of a 120 ohm resistor here, which is its source impedance of 120 ohms, and this resistive divider here with these values marked with a star. And then you have a DP/DT switch to disconnect the amplifier from the speakers and then connect it to the headphones. And down here in table 1 is the resistor values for different power outputs. Now, my board uses the DP/DT switch inside the headphone socket to disconnect the power amplifier from the speakers, and any higher than probably 20 watts, the board probably would not be suitable to switch the speakers in and out directly. So you'd have to use an external switch or relay. However, here is the values for R1 and R3, and my power amplifier into 8 ohms is roughly 10 watts nominal. So R1 is a 100 ohm resistor and it only needs to be half watt, but I'm using a 1 watt device just in case. And R3 is a 47 ohm resistor. And these are all the values you use and their wattages for different power outputs, and that's roughly what the voltage at the output would be in RMS. Version 2's slightly different and a little bit simpler, but it uses a 5 watt 2.2 ohm resistor, and this is designed to keep its output impedance to roughly 2 ohms, and is basically designed for lower impedance headphones that are less than 120 ohms. So like, for example, earbuds, which will not work with version 1. So I'm going with version 1. I'm going to breadboard up all these components, hook it up to the amplifier and test it. Okay, I've got the circuit built up on the breadboard here. This is just the dummy load. It's about 49 ohms, which is pretty close to the impedance of my headphones. Got the scope in ×1. Turn the amplifier on. I've verified nothing's shorted. And we do have an output. Nice. Currently about 100 millivolts. So if I wind the volume up, right, I'm overshooting the screen. We're into clipping. About 5 volt peak to peak, which is okay. Okay, it's now hooked up to my headphones, but I'm not wearing them. I can hear the sound coming out. It's not terribly loud. There's 550 millivolts going in from the oscillator. Now I'll just disconnect the oscillator. I can hear a slight hum through the headphones, but it's not annoying. Beauty, so that circuit works as intended. Alright, well, I've got the headphone adapter board built now. It was pretty painless. This connector just fits in the holes that I designed the footprint for, so that's great. I've got a couple of standoffs on there too, which are going to be roughly the right height. They're probably, if anything, a millimeter too short. I'll find that out if I decide to actually include it into the amplifier. Once I've drilled the hole in the front panel, how much distance I've got to take up or take off of this thing. So yeah, and because there's no real guaranteed method to get the center point of where the center of the socket is compared to each of these standoffs, basically drill the hole in the front panel, pass it through remove one of the standoffs and then run the drill bit right through the PCB into the bottom of the cabinet, just to drill the holes and make sure that everything lines up. It's going to be a bit of a cluster, but that's what it is. Now I've already got a ground wire on there, but it's probably a bit too thick for the purpose, but eh. So now all I've got to do is I've got to test it to make sure that it works. Now I've already confirmed that the left in connects to the left out and the right in connects to the right out when there's no plug inserted. It does. I also confirmed that it disappears when a plug is inserted. The only thing I don't know is if the sound is going to come out the socket. So that's the next thing I've got to test. Okay, so while I've still got the oscillator set up from a previous test in a previous video, I thought I would now test the functionality of this headphone adapter. I've got it bodged in. I've got the ground over to the star. I've soldered in temporary wires and connected it directly to each output channel. I don't care if the signal's coming out at this point here. I know it is due to continuity tests. All I'm interested in now is if the signal is coming out evenly on the socket here. So I'll turn it on and we won't hear anything because I don't have a speaker connected. And I will hook up the headphones. I haven't got a signal. Well, I can hear it, but it's not very loud. Not sure why. Right, it's louder on the left than it is on the right. I don't know. Oh, there we go. Wasn't plugged in properly. Okay, so I'll kill my sound. You can't hear it. Now, I can hear a little bit of the mains hum coming through, but it's not that terrible. It's certainly, you can certainly put up with it, put it that way. So I now know that this headphone adapter is working, and the level is about right for my headphones. You may have to experiment with the resistor values. Look on Rod Elliott's site for this particular article project. There is a link in the description for it. So you just choose your values to suit whether or not you've got not enough gain or too much gain coming into your headphones. So you just adjust the resistor values according to his table. I'm still in two minds of whether I'm going to include this in the case, but I'm still uploading this video basically on its own rather than part of the project, because this type of idea is quite a very handy little circuit, and the PCBs will be made available in the description also if you want to order them. Alright, I've decided to go for it, balls and all. I've got the front panel off and completely disassembled. I've got my mark roughly 115mm in from the inside edge of the case, not the outside. So it puts it roughly in between the center of the power switch and the base pot. So it'll look a little bit more even that way, I think, anyway. Now, I believe I've got to drill out the hole to 10mm. Right, because these sockets are really hit and miss sometimes. It does look like 10mm to me. Maybe 10.5, some obscure measurement. So I need to center punch this and drill a pilot hole. And as I've always said, everything's a hammer. That should be right. The drill's gearbox in this thing is starting to get fairly noisy. Okay, so I now need to size this hole out to 10mm with my star drill bit, Christmas tree bit, stepper bit, whatever you want to call it. Okay, I got the hole drilled. Socket fits through it. It's slightly larger than 10mm. It's actually more like 10.5. So I used the star bit to ream the hole out a little.
Yes, it's got an imperfection on the front, but I can fill that in with texture before I spray it with the final protectant. Okay, so now that fits in through the hole nicely, it's like, you know, something like that. It won't look too bad on the front panel. So now what I've got to do is I've got to put it all back together in the case, everything, and then work out where to drill the holes for the mounting points. Alright, the panel's back on, but I can see right away that there's a good significant gap here between the standoff and the bottom of the case, and I reckon it's about the size of an M3 nut, maybe an M3 nut and a washer. So I don't know if these standoffs come in 12mm long. This is a 10mm one. I've got 15, but I haven't got 12. Unless nylon ones are 12mm long. I'll have to have a look at my stock, see what I've got. If I've got a 12mm one, well, it'll save a lot of messing around. It does look like 12mm is about right. I can't really tell if this board's sitting up at an angle. It is kind of hard to tell, but according to the socket at the front, it looks relatively straight. So, the only problem is these nylon spacers aren't as strong as the metal ones, but it certainly might do the job. So now, the tricky part. I've now got to drill the holes into the bottom of the case where this board sits, which is really going to be awkward. So I'm going to try something. Okay, so I've taken one standoff off and I've left the other one on. So I'm going to get this roughly where it looks right. Pass the drill bit through the PCB. That gives me a mark to work with. Of course, my drill's going flat now, isn't it? Alright, so I'm going to get all the stuff out of the case now. I'm going to do the same thing again, but I'm going to take the standoff off the other side of the PCB, put it on the whole side where I've just drilled, mount it to the case, drill the second one, and it should be, for all intents and purposes, as straight as I can get it. Well, it's in there, but it's not exactly straight. It is slightly crooked off to the left, but it's not too bad. I mean, not too bad for not measuring it. Would have been easier to measure it, but it would have been easier if it was done when I was first laying out the bottom panel. But this headphone adapter was kind of an afterthought. Alright, so the board needs to come back out. I need to get rid of these bloody wires here. And I need to figure out if I can have enough cable length on these cables here to actually break into the speaker in, speaker out connections. Well, considering the input's over here and the output's over there, it should be enough wire there. So that's what I'm going to do, is I'm going to do that, reassemble the whole entire thing, because it's still sort of sitting in pieces here. I haven't even got the power switch hooked back up yet. So I'll get to doing that, and we'll come back when I think I've done this. But before I do that, it might be a good idea to check the mechanical strength. Oh yeah, that should be fine. I mean, albeit it's crooked. If it annoys me, I can always just like ream those holes out a little bit more. Maybe even make them up to like 3.5 or something. Currently they're drilled to 3.2. So yeah, I might decide that after I take this apart for a final time to actually do the labelling. It's got to come apart again anyway, so yeah, I'll think about that once I come to do the labelling. Right, I thought this was going to be more difficult to do with it being still in the case, but it's actually easier that I just took the wires out of the case. Makes it easier to strip them, makes them easier to solder to the board. Now, I don't know if I mentioned already, but I'm soldering the wires directly to the board because the connectors are too high for the case. They'll interfere with the top of the lid, which is not what I wanted to do. So that's why I'm hardwiring it to the board. Now I've lost my left one. Here's my left one. This third hand on this little jig thing is very handy for holding the wires still whilst you're trying to, you know, solder them into the board. Because it will hold it nice and straight for you. Although it is difficult soldering on an angle. And that totally did not solder, because there's too much solder on the end of my tip. Let's try that again. There we go. Right, I think that's the wires soldered, and the wires inside the case from the power supply back to the output socket were just long enough to patch into, so I don't have to make any new cables, which is always a bonus. And there it is, all completed there. Now if you're wondering why I was using heat shrink on the wires there, it was just so that I could denote which was the left, which was the right, so I didn't mix them up. That's the only purpose to the heat shrink, it's not serving any other purpose. Right, so now I need to put all this back in the case and test it. So hopefully this goes without a problem. And there it is, all there back together in its home and recable tied and put back through the little eyelet things here. I ended up redoing the star earth ground stud because it was getting too short and the nut was awfully hard to put on there. Plus it decided to come undone. So now I put a 20mm screw in there, and there's now two nuts on the bottom here, one up real tight and then there's another one on top to stop the other one backing off. Washer, the eyelets, another washer and a nut. So everything's wired in. So yeah. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe. No, I'm not serious. I am going to test it, which probably would be a good idea considering I've done all this work. I mean, but it is starting to come on. I'm quite happy with how it's turned out. The mains noise coming out the speaker, the slight hum there is, yeah, an issue. I'm not sure what's causing that. It could be the way my grounding is. Maybe the power amps need to come directly off the star earth for the negative, but I'll sort that out later when I want to finalise it a little bit more with some, you know, text on the screen. I should put another cable tie there too. It's missing one. So yeah, well, I'll plug it in and I'll turn it on and see if it still even works. I'll hook up a speaker to the left and see if we've got an output signal. Yeah, we'll just go from there. Alright, it's set up. So what I want to know first is, does the thing still work, for a start? And B, is there any unusual noises coming out the speaker because of this extra board? So I'll turn it on. Power's up at least. Can't hear any unusual noises coming out the speaker. Yeah, that's still working. So what I'm going to do is I'm going to plug a pair of headphones in and see if I can hear the signal coming out of the left hand side. I can hear hum, so yep, and it's not coming out the speaker now, which is the idea. Now coming out the speaker, I'll move over to the right channel. It's going to be harder to get a blurt out of it. Alright, got an RCA lead hooked up now. It's coming out the right. Coming out the right. Both channels are working. Yay. Well, I'm extremely happy with that. Not quite, because it's not as flush with the front panel as I wanted, but that's actually not a bad thing because that may now hide the exposed aluminium a bit better, which I am going to go around with a bit of black paint or something before I spray the panel. Same around these LED holes. That's about the only two holes I have to worry about, is the LED holes and the headphone socket hole. But yeah, it's working. It does what it's supposed to do. So that's where I'm going to leave this video here. In the next video it'll be kind of like finalising the front panel lettering and the rear panel lettering and spraying it with some protective clear coat. So that'll be that. And I've also ordered some knobs, some nice hi-fi looking black knobs from RS Components on the mainland. I'm not sure which one it's coming from. There's one in Adelaide, one in New South Wales, I think there's one in Perth. Anyway, wherever it's coming. They should be here tomorrow, if not Monday. And it cost me $54 for it. One knob was $12.95 and the other four knobs, 1, 2, 3, 4, were, I think they're about the $9 mark or something. I'll share that information with you when I've got the invoice in front of me. But the total order was like $38, I think, for the parts, plus $12 overnight delivery. So, yeah, and the largest knob for the volume, I believe, is 18.5 millimeters, and the other four was something like about 14 millimeters. I actually can't remember, to be honest. It's not really relevant at this point. That'll all be explained in I'm hoping a final video so I can finish this project, put the lid on, and have completed it. So it's been a journey. It's taken me, I don't know, about 2 months now, maybe 3, to do all the CAD design, the testing, and the building, getting the components, having the PCBs made, and all that sort of jazz, as well as getting the rack case and the transformer, which was 2 separate transactions from Ultronics, but that's alright. Because I was wondering with Ultronics why I had to have a minimum of $20 for the order. And I thought, well, hang on, when I ordered this switch, originally, I didn't order anything else. And then I remembered, no, I ordered the transformer at the same time. Dope! Anyway, so that's going to conclude this video, and I hope you enjoyed it. And if you did, please remember to go down the bottom there and rate, comment and subscribe as usual. And the links to my Facebook and Patreon are in the description as usual. Anyway, I'm going to leave a link in the description to Rod Elliott's project or article on these headphone adapters for you to peruse at. It's not just for this project, but it's for any amplifier. As I said, if you're going to use a power amplifier above 20 watts, I would not use the internal DP-DT switch of the headphone socket to disconnect speakers. Even though they used to do that in amplifiers in the day anyway, but it's not a good idea. The contact rating is just not high enough. Anyway, I'm the Astro 30. Thanks for watching. See you in the next one.